Question 1. Thermodynamics. Gibbs free energy and spontaneity. Spontaneity of a chemical reaction is often determined by the Gibbs free energy change, dg. Consider reaction occurring in closed system at constant temperature and pressure. The reaction initially has large negative dg, but over time dg approaches zero. Which of the following best explains the behavior of the system? A. The reaction releases heat and is exothermic, so dg naturally trends towards zero. B. As the reaction proceeds, the system moves toward equilibrium where E equals zero. C. The concentration of reactants increases, reversing the reaction, which caused dg to approach zero. D. The activation energy is high, preventing the reaction from proceeding, so dg remains unchanged. Answer. B. As the reaction proceeds, the system moves toward equilibrium where E equals zero. Explanation. Gibbs free energy dg is measure of the spontaneity of process. Reaction is spontaneous if dg is negative. However, as the reaction progresses, the reactants are consumed and products accumulate. Eventually, equilibrium is reached where E equals zero and no further net reaction occurs. Y is incorrect. Exothermicity, release of affects dH, enthalpy, not necessarily dg. Reaction can be exothermic and still non-spontaneous if entropy changes unfavorably. YC is incorrect. Reactant concentration decreases over time, not increases. If reactants increased, the system would move away from equilibrium, not toward it. YD is incorrect. Activation energy, E, affects the rate of reaction but does not determine whether dg approaches zero over time. Equilibrium, not activation energy, dictates the final value of dg. Key concept: at equilibrium d equals zero, meaning there is no driving force for further net reaction. Question 2. Chemical bonding, molecular orbital theory and bond order. Oxygen molecules O exhibit unique magnetic properties due to their molecular orbital configuration. Which of the following statements correctly explains why O is paramagnetic? A. The presence of unpaired electrons in the antibonding p orbitals causes paramagnetism. B. Oxygen has an incomplete octet, and the need to complete its octet makes it paramagnetic. C. The unpaired electrons in the valence shell of atomic oxygen remain unpaired when forming O molecules. D. The ionic nature of the O molecule results in delocalization of electrons, leading to magnetism. Answer A. The presence of unpaired electrons in the antibonding p orbitals causes paramagnetism. Explanation. Molecular orbital theory Mott explains the electronic structure of molecules better than Lewis structures. According to Mott, has an electronic configuration of SS, 2SS, 2sp, 2pp, 4pp, 2y is correct. The presence of two unpaired electrons in the antibonding p orbitals lead paramagnetism. Magnetic behavior YB is incorrect. Oxygen does not have an incomplete octet in O. Each oxygen atom in O has complete valence shell. YC is incorrect. In atomic oxygen, unpaired electrons exist, but when forming O, most electrons pair up except for two in p orbitals. YD is incorrect. O is covalent, not an ionic molecule. Ionic compounds exhibit different types of magnetic behavior than molecular orbital interactions. Key concept: O is paramagnetic because it has two unpaired electrons. Molecular orbital structure. Question 3. Surface chemistry, adsorption and its types. Industries use activated charcoal for removing pollutants from air and water. The effectiveness of charcoal is due to which of the following adsorption properties? A. Activated charcoal undergoes physical adsorption, where weak van der Waals forces attract pollutants to its surface. B. Activated charcoal undergoes chemical adsorption, where pollutants form strong covalent bonds with its surface. C. Activated charcoal releases free radicals that neutralize pollutants. D. Activated charcoal forms ionic bonds with pollutants, trapping them permanently. Answer. Activated charcoal undergoes physical adsorption, where weak van der Waals forces attract pollutants to its surface. Explanation. Adsorption is the process where molecules from a gas or liquid phase accumulate on a solid surface. Y is correct. Activated charcoal works mainly by physical adsorption. Physadsorption. Due to its high surface area and porous structure, it attracts pollutants through van der Waals forces, making it highly effective. B is incorrect. Chemical adsorption, chemosorption, involves covalent bonding, which is much stronger but is not the primary mechanism in charcoal adsorption. YC is incorrect. Charcoal does not release free radicals. Instead, it simply captures pollutants. YD is incorrect. Charcoal adsorption does not involve ionic bonding, as it can adsorb non-ionic molecules as well. Key concept. Physadsorption is the primary mechanism. Charcoal adsorption, making it an effective air and water purifier. Question 4. Scenario-based. Redox reactions, electrochemical cells, and Nernst equation. Mr. Arjun is an engineer designing a backup power system for a hospital. He decides to use a lead-acid battery because it is rechargeable. However, he notices that after prolonged usage, the battery is failing to hold a charge. Which of the following is the most likely reason for this failure? A. The battery undergoes excessive sulfation, reducing the effectiveness of the lead electrodes. B. The battery's electrolyte becomes more concentrated, increasing its efficiency. C. The battery's electrodes corrode due to the continuous flow of electric current. D. The battery generates hydrogen gas, leading to an explosive failure. Answer A. The battery undergoes excessive sulfation, reducing the effectiveness of the lead electrodes. Explanation why is correct. In lead-acid batteries, repeated charging and discharging cause the formation of lead sulfate PbSO. Over time, this sulfation builds up, reducing the battery's ability to function. Why B is incorrect. The electrolyte in lead-acid battery dilutes over time due to electrochemical reactions, not becomes more concentrated. Why C is incorrect. Corrosion can happen but is not the main reason for battery failure. Sulfation is the primary issue. Why D is incorrect. While hydrogen gas can be produced in lead-acid batteries, proper ventilation explosions. Key concept. Sulfation reduces battery efficiency by covering electrodes with lead sulfate, preventing proper charge flow. Question 5. Chemical kinetics, order of reactions, and rate laws. The decomposition of ammonia on a platinum surface follows zero-order kinetics. Which of the following correctly explains why the reaction rate remains constant despite decreasing reactant concentration? A. The reaction occurs at a constant temperature, so the rate does not change. B. The reaction is independent of ammonia concentration because the catalyst surface is saturated. C. The reaction is in equilibrium, preventing any further change in rate. D. The rate constant is high, so concentration changes do not affect the rate. Answer B. The reaction is independent of ammonia concentration because the catalyst surface is saturated. Explanation. Zero-order reactions exhibit constant reaction rates that do not depend on the concentration of reactants. Why B is correct. In the decomposition of NH on platinum, the catalyst's surface becomes saturated with ammonia molecules. Since the catalyst is fully occupied, additional reactant molecules do not increase. Reaction rate. Why is incorrect. Temperature affects rate constants but does not determine reaction order. Why C is incorrect. The system is not necessarily at equilibrium, and equilibrium does not mean a constant rate. Why D is incorrect. High rate constant K does not make reaction zero order. Order is determined by mechanism, not rate constant magnitude. Key concept. Zero-order kinetics occurs when reaction is limited by surface or enzyme rather than reactant concentration. Question 6. Coordination chemistry, crystal field theory and magnetic properties. A coordination complex contains a transition metal ion with a strong field ligand. According to crystal field theory, CFT, which of the following properties is most likely? The complex is low spin, meaning fewer unpaired electrons and weak magnetism. B. The complex is high spin, meaning more unpaired electrons and strong magnetism. C. The complex undergoes sp hybridization, making it tetrahedral. D. The complex has delocalized p bonding, leading to high electrical conductivity. Answer A. The complex is low spin, meaning fewer unpaired electrons and weak magnetism. Explanation why is correct. Strong field ligands like CN create large crystal fields splitting energy D. This forces electrons to pair up in lower energy orbitals, leading to low spin complexes with fewer unpaired electrons and weaker magnetic properties. Why B is incorrect. High spin complexes form when weak field ligands like Cl are present, leading to more unpaired electrons. Why C is incorrect. sp hybridization is typical for tetrahedral complexes, but strong field ligands usually favor octahedral coordination. DSP hybridization. Why D is incorrect. Delocalized p bonding is not primary factor in coordination complexes magnetism. Conductivity is generally associated with metals or conjugated systems, not ligand fields. Key concept. Strong field ligands cause low spin complexes with weak magnetism due to paired d electrons. Question 7. State of matter, intermolecular forces, and liquefaction of gases, liquid oxygen O and nitrogen Nn can be stored at cryogenic temperatures, while helium heat requires much lower temperatures to liquefy. What is the primary reason helium is more difficult to liquefy than oxygen or nitrogen? A. Helium atoms lack significant intermolecular forces, requiring extremely low temperatures to condense. B. Helium has lower molecular weight than oxygen or nitrogen, preventing liquefaction. C. Helium is highly reactive and forms no stable liquid phase. D. The strong dipole-dipole interactions in helium prevent condensation. Answer A. Helium atoms lack significant intermolecular forces, requiring extremely low temperatures to condense. Explanation why is correct. Helium is a noble gas with only weak London dispersion forces induced dipole interactions. Since these forces are very weak, helium remains gaseous even at very low temperatures. It requires near absolute zero temperatures to liquefy. YB is incorrect. Molecular weight affects points but is not the main reason helium is difficult to liquefy. Intermolecular forces play a bigger role. Why C is incorrect. Helium is inert, not highly reactive. It does not form compounds but can exist as a liquid under extreme conditions. Why D is incorrect. Helium atoms do not have dipole-dipole interactions as they lack permanent dipoles. Key concept: weak intermolecular forces make helium extremely difficult to liquefy, requiring cryogenic conditions. Question 8. Chemical thermodynamics. Spontaneity and entropy changes. A reaction occurs in a closed system at constant pressure. The reaction is exothermic and results in an increase in entropy. Based on the Gibbs free energy equation, which of the following conclusions can be drawn about the spontaneity of the reaction at all temperatures? A. The reaction is always spontaneous because dH is negative and ds is positive. B. The reaction is never spontaneous because an increase in entropy always requires energy input. C. The reaction is spontaneous only at low temperatures when enthalpy dominates. D. The reaction is spontaneous only at high temperatures when entropy dominates. Answer A. The reaction is always spontaneous because dH is negative and ds is positive. Explanation: the Gibbs free energy equation ds EH is negative exothermic and ds is positive entropy increase, then dG is always negative, making the reaction spontaneous at all temperatures. YB is incorrect. Entropy increase does not necessarily require energy input. Spontaneity depends on the balance of enthalpy and entropy. YC and D are incorrect. The reaction does not depend on temperature for spontaneity. Key concept: reaction is always spontaneous if isothermic and increases entropy. Question 9. Chemical bonding, molecular shape, and hybridization. The SF molecule has seesaw shape due to the presence of lone pairs. Which of the following best explains why its shape deviates from perfect tetrahedral or trigonal bipyramidal geometry? A. The sulfur atom undergoes sp hybridization, leading to electron pair repulsion. B. The presence of one lone pair distorts the trigonal bipyramidal shape, pushing bonded atoms closer. C. The molecule follows the octet rule strictly, forcing perfect tetrahedral shape. D. Sulfur's high electronegativity prevents electron repulsion effects. Answer B. The presence of one lone pair distorts the trigonal bipyramidal shape, pushing bonded atoms closer. Explanation: YB is correct. SF has trigonal bipyramidal electronic geometry, but the presence of one lone pair at the equatorial position distorts the shape into seesaw geometry. The lone pair bond pair repulsions push bonded atoms closer together. Y is incorrect. SF undergo SPD hybridization. No SB. Y. Incorrect. The octet rule is expanded for sulfur, allowing more than 8 valence electrons. YD is incorrect. Electronegativity does not directly affect molecular shape, but electron repulsions do. Key concept: lone pairs cause molecular distortion due to stronger repulsions compared to bonding pairs. Question 10. Electrochemistry, redox reactions, and electrode potentials. Which of the following explains why alkali metals like Nau and K are never found in nature as pure metals? Say, alkali metals are strong oxidizing agents, so they react easily with oxygen. B. Alkali metals have high ionization energies, making them highly reactive. C. Alkali metals have low reduction potentials, meaning they are easily oxidized. D. Alkali metals are covalent in nature, preventing them from existing as pure metals. Answer C. Alkali metals have low reduction potentials, meaning they are easily oxidized. Explanation: alkali metals, group 1 elements, have very low standard reduction potentials, meaning they easily lose electrons and oxidized form stable cations. Y is incorrect. Alkali metals are strong reducing agents, not oxidizing agents. YB is incorrect. Alkali metals have low ionization energies, making electron loss easy. YD incorrect. Alkali metals form metallic bonds, not covalent bonds. Key concept: alkali metals are highly reactive due to their low reduction potentials, making them exist as compounds rather than free metals in nature. Question 11. Surface chemistry, colloids, and adsorption phenomena. Which of the following statements correctly describes how protective colloids stabilize colloidal dispersions? A. Protective colloids form hydration shells, preventing coagulation by repelling charged particles. B. Protective colloids act as electrolytes, neutralizing surface charge and stabilizing the system. C. Protective colloids introduce strong dipole-dipole interactions, increasing solubility. D. Protective colloids remove Brownian motion, preventing particle movement. Answer A. Protective colloids form hydration shells, preventing coagulation by repelling charged particles. Explanation. Protective colloids form hydration layers around dispersed particles, preventing aggregation. Why B is incorrect. Electrolytes destabilize colloids by reducing repulsion, leading to coagulation. Why C is incorrect. Dipole-dipole interactions do not control colloidal stability. Why D is incorrect. Brownium actually helps colloid stability by preventing settling. Key concept: protective colloids prevent aggregation by forming hydration shells that repel particles. Question 12. Atomic structure, photoelectric effect, and ionization energy. Why does the ionization energy of noble gases decrease down the group despite their full electron configuration? A. Increased nuclear charge attracts outer electrons more strongly. B. Increased atomic radius and shielding reduce effective nuclear attraction. C. Noble gases lose electrons easily due to their filled valence shells. D. Noble gases form stable cations, making ionization easier. Answer B. Increased atomic radius and shielding reduce effective nuclear attraction. Explanation. Why B is correct. As noble gases increase in size down the group, their outermost electrons are farther from the nucleus. Increased shielding reduces nuclear attraction, lowering ionization energy. Why is incorrect. While nuclear charge increases, shielding dominates, leading to lower attraction. Why C and D are incorrect. Noble gases do not lose electrons. They are chemically inert. Key concept: ionization energy decreases down a group due to increased atomic size and electron shielding. Question 13. Chemical kinetics, rate laws, and reaction mechanism. In a reaction, the rate law is found to be R equals Ka2B if the concentration of is doubled and the concentration of B is halved. How does the reaction rate change? A. The rate remains unchanged. B. The rate increases by a factor of 2. C. The rate decreases by a factor of 4. D. The rate increases by a factor of 4. Answer C. The rate decreases by a factor of 4. Explanation. The rate law is given as R equals Ka2B. When A is doubled, the rate will increase by a factor of 20 to equal 4. When B is halved, the rate will decrease by a factor of 1, 2. Thus, the overall change in rate will be factor of 4x1 equals a decrease. The correct option is C. Key concept: reaction rate is affected by the concentration of reactants raised the power of their respective orders. Question 14. Chemical thermodynamics gives free energy and equilibrium. The reaction N(G) plus 3 E equals to 1. G occurs at high temperatures. Which of the following will decrease the equilibrium concentration of ammonia NH? A. Increasing the temperature. B. Increasing the concentration of hydrogen H. C. Increasing the pressure. D. Decreasing the volume of the system. Answer A. Increasing the temperature. Explanation. The reaction is exothermic, so according to Le Chatelier's principle, increasing temperature shifts the equilibrium towards the reactant's left to absorb the added heat. Why B is incorrect. Increasing H will shift equilibrium towards NH production. Right. Why C and D are incorrect. Increasing pressure or decreasing volume favors the side with fewer moles of gas, which is the right side. In ammonia concentration. Key concept: the equilibrium of an exothermic reaction is shifted towards reactants at high temperatures. Question 15. Electrochemistry, electrode potentials and cell potential for the reaction ZnS plus Q AC ZnAC plus Q S. The standard electrode potentials are EDEG with 0.34 V and EDA will negative 0.76 V. What is the standard cell potential for this reaction? A. 1.10 V. B. Negative 1.10 V. C. 0.50 V. D. 0.34 V. Answer A. 1.10 V. Explanation. The standard cell potential is calculated using EDIG cells, EDIG cathode, EDIG anode. QQ is the cathode, reduction half reaction, and EAN is the anode, oxidation half reaction. EDIG cell was 0.34 V. 0.76 V equals 1.10 V. Correct option is A. Key concept. The standard cell potential for reaction is the difference between the cathode and anode potentials. Question 16. Atomic structure, quantum numbers, and electron configuration. Which of the following set of quantum numbers corresponds to an electron in the 3p orbital of an atom? Equals 3 equals 1 equals 0 equals 1 wo. Equals 3 equals 1 equals 1 equals zekative wo. Equals 1 equals zekative 1 equals 1 wo. Equals or equals 0 equals 0 equals zekative 1 wo. Answer. A equals 3 equals what equals 0 equals 1 wo. Explanation. For the 3p orbital, the principal quantum number equals 3 and the angular momentum quantum's number equals 1. For p orbitals, the magnetic quantum number m can range from -1 to 1 for equals 1, so equals 0 is valid. The spin quantum number s can be 1 wo or -1 wo, so 1 wo is valid. Correct option is A. Key concept. Numbers describe the position and energy of an electron in an atom. Question 17. Organic chemistry, isomerism, and functional groups. Which of the following statements is true about cis-trans isomerism in alkenes? A. Cis isomers have bulky groups on opposite sides of the double bond, leading to higher stability. B. Trans isomers are more stable than cis isomers due to steric repulsion between the bulky groups. C. Cis-trans isomerism occurs only in alkenes with two identical substituents. D. Cis-trans isomerism is observed in compounds that do not have a double bond. Answer. B. Trans isomers are more stable than cis isomers due to steric repulsion between the bulky groups. Explanation. Trans isomers are more stable than cis isomers because the bulky groups are on opposite sides of the double bond, reducing steric repulsion. Y is incorrect. Cis isomers have bulky groups on the same side of the double bond, causing more steric hindrance, making them less stable. Y, C, and D are incorrect. Cis-trans isomer is characteristic of alkenes with different substituents at the double bond. Key concept. Cis-trans isomerism is a type of stereoisomerism observed in compounds with a rigid double bond. Question 18. Chemical bonding and molecular structure, hybridization and bonding theories consider a molecule of Bf. The central boron atom is bonded to 3 fluorine atoms. Which of the following statements correctly describes the hybridization of the central boron atom and the molecular geometry of Bf? The central boron atom undergoes sp hybridization and the molecule adopts trigonal planar geometry. B. The central atom undergoes sp hybridization and the molecule adopts linear geometry. C. The central boron atom undergoes sp hybridization and the molecule adopts tetrahedral geometry. D. The central boron atom undergoes dsp hybridization and the molecule adopts octahedral geometry. Answer A. The central boron atom undergoes sp hybridization and the molecule adopts trigonal planar geometry. Explanation. Bf has trigonal planar molecular geometry. This geometry arises because the boron atom has 3 bonding pairs and no lone pairs of electrons. The central boron atom undergoes sp hybridization, which forms 3 sigma bonds with the fluorine atoms. Correct option is A. Key concept. Molecular geometry and hybridization are determined by the number of bonding pairs and lone pairs around the central atom. Question 19. State of matter, kinetic theory of gases and gas laws. In a given sample of an ideal gas, the volume is kept constant and the temperature is increased. Which of the following statements correctly explains the behavior of the gas under these conditions? A. The pressure will remain constant as the gas is in a closed container. B. The pressure will increase because the gas molecules will collide with the walls of the container more frequently. C. The volume will decrease as the temperature increases. Following Boyle's law. D. The temperature change will have no effect on the behavior of the gas as it is ideal. Answer. B. The pressure will increase because the gas molecules will collide with the walls of the container more frequently. Explanation. According to the kinetic theory of gases, as the temperature of a gas increases, the kinetic energy of the gas molecules also increases, leading to more frequent collisions with the walls of the container. This results in an increase in pressure as the pressure is directly proportional to temperature at constant volume in accordance with Gay-Lussac's law. Correct option is B. Key concept. In an ideal gas, pressure is directly proportional to temperature at constant volume. Gay-Lussac's law. Question 20. Thermodynamics. First law of thermodynamics and internal energy during a chemical reaction. Do represents the change in internal energy of the system. If the system does work on the surroundings and heat is absorbed by the system, which of the following statements is true about the relationship between heat, work, and internal energy? A. The change in internal energy. Do is the sum of heat absorbed and work done on the system. B. The change in internal energy due is the difference between the heat absorbed and the work done by the system. C. The change in internal energy due is the same as the heat absorbed by the system. D. The change in internal energy due is zero if no work is done during the process. Answer B. The change in internal energy due is the difference between the heat absorbed and the work done by the system. Explanation. According to the first law of thermodynamics, U equals W, where Q is the heat absorbed by the system and W is the work done by the system. If the system does work on the surroundings, W is positive and heat is absorbed, so due is the difference between the heat absorbed and the work done. Correct B. Key concept. The first law of thermodynamics states that the change in internal energy is the sum of heat absorbed and the work done on the system. Question 21. Chemical equilibrium. Le Chatelier's principle. Consider the equilibrium reaction. NN plus 3 E equals to 1 G. If the temperature is increased, what will happen to the concentration of ammonia NH at equilibrium? A. The concentration of ammonia will increase as the reaction shifts to the right. B. The concentration of ammonia will decrease as the reaction shifts to the left. C. The concentration of ammonia will remain constant regardless of temperature changes. D. The concentration of ammonia will increase until the reaction reaches complete conversion. Answer B. The concentration of ammonia will decrease as the reaction shifts to the left. Explanation. The reaction is exothermic, meaning it releases heat. According to Le Chatelier's principle, increasing temperature will shift the equilibrium towards the reactant's left to absorb the added heat, causing a decrease in the concentration of ammonia. Correct option is B. Key concept. For exothermic reactions, increasing temperature shifts the equilibrium towards reactants. Question 22. Ionic equilibrium, buffer solutions and EA. A student prepares a buffer solution by mixing equal amounts of a weak acid and its conjugate base. What will happen to the pH of the solution if a small amount of a strong acid is added? A. The pH will decrease significantly due to the addition of hydrogen ions. B. The pH will remain unaffected as the buffer solution neutralizes the acid. C. The pH will increase as the buffer will absorb the added protons. D. The pH will decrease slightly, but the buffer will still maintain the original pH. Answer A. The pH will decrease significantly due to the addition of hydrogen ions. Explanation. A buffer solution resists changes in pH on the addition of small amounts of acid or base. When a strong acid is added, the conjugate base in the buffer solution reacts with the added H ions to neutralize them. This causes slight decrease in pH, but not as much as it would without the buffer. Correct option is A. Key concept. Buffer solution consists of weak acid and its conjugate base, which helps maintain stable pH when small amounts of acid or base are added. Question 23. Redox reactions and electrochemistry. Balancing redox reactions. Consider the following unbalanced redox reaction that occurs in an acidic medium Mn plus Cumpa Mn plus Co. What is the correct method to balance this reaction using the ion electron method? A. The number of electrons involved in oxidation and reduction are equal, so we can directly combine the half reactions without further adjustments. B. We balance the half reactions first by adjusting the coefficients for Mn and Co, then add electrons to balance the charges. C. We balance the number of atoms first, then add electrons to balance the charges, and finally add water molecules to balance the oxygen atoms. D. We start balancing the oxygen atoms with water, then balance the hydrogen atoms using H ions, and finally add electrons to balance the charges. Answer D. We start by balancing the oxygen atoms with water, then balance the hydrogen atoms using H ions, and finally add electrons to balance the charges. Explanation. In the ion electron method, the steps are: balance the oxygen atoms using H molecules, balance the hydrogen atoms by adding H ions, add electrons to balance the charges. The process ensures both mass and charge are balanced in the reaction. Correct option is D. Key concept. The ion electron method involves balancing atoms and charges step by step, starting with oxygen and hydrogen. Question 24. Chemical kinetics, rate of reaction and order of reaction. In a chemical reaction, the rate law is given as ρ equals Ka. B2. Which of the following statements is true about the order of the reaction and its implications for reaction rates? A. The reaction is first order with respect to A, second order with respect to B, and third order overall. B. The reaction rate depends on the concentration of raised to the first power and B raised to the second power, making the overall order 2. C. The rate law indicates that the concentration of does not influence the rate of reaction. D. The rate of the reaction will decrease if the concentration of B is doubled because the rate law has negative exponent for B. Answer A. The reaction is first order with respect to A, second order with respect to B, and third order. Overall explanation. The rate law indicates that the reaction is first order with respect to A and second order with respect to B, so the overall order is third order. The rate of reaction is directly proportional to the concentration of A and the square of the concentration of B. Correct option is A. Key concept. The order of a reaction determined by the exponents of the concentration terms in the rate law. Question 25. Surface chemistry, adsorption and adsorption isotherms. Which of the following statements correctly explains the difference between adsorption and absorption, and how do Freundlich and Langmuir adsorption isotherms explain the behavior of gases on solid surfaces? A. Adsorption refers to the accumulation of molecules on a surface, while absorption refers to the penetration of molecules into the bulk of the material. The Freundlich isotherm applies to adsorption on heterogeneous surfaces, while the Langmuir isotherm assumes a monolayer of adsorbate on a homogeneous surface. B. Adsorption involves the entry of molecules into the bulk of the material, while absorption involves the accumulation of molecules on the surface. Both Freundlich and Langmuir isotherms explain adsorption at very low pressures only. At C. Adsorption is a reversible process, whereas absorption is irreversible. The Langmuir isotherm is more accurate for gases adsorbed onto liquid surfaces. D. Adsorption leads to the increase in the volume of the substance being adsorbed, and absorption involves an increase in surface area. Freundlich isotherm assumes that the adsorbate molecule form multiple layers. Answer A. Adsorption refers to the accumulation of molecules on a surface, while absorption refers to the penetration of molecules into the bulk of the material. The Freundlich isotherm applies to adsorption on heterogeneous surfaces, while the Langmuir isotherm assumes a monolayer of adsorbate on a homogeneous surface. Explanation. Adsorption refers to the accumulation of molecules on the surface, while absorption is when molecules incorporated into the bulk of the material. Freundlich isotherm is used for heterogeneous surfaces and assumes that adsorption sites have different energies, while the Langmuir isotherm assumes a monolayer of adsorbate on a homogeneous surface. Correct option is A. Key concept. The Freundlich and Langmuir isotherms describe adsorption behavior under different surface conditions. Question 26. Thermodynamics, Gibbs free energy and spontaneity. Consider a spontaneous reaction with a positive change in enthalpy dH0 and positive change in entropy ds0. Which of the following conditions must be true for this reaction to be spontaneous at all temperatures? A. The reaction will be spontaneous at high temperatures if the enthalpy change is large enough. B. The reaction will always be non-spontaneous at all temperatures. C. The reaction will be spontaneous only at low temperatures because the positive entropy change outweighs the enthalpy change. D. The reaction will never be spontaneous because both dH and ds are positive. Answer A. The reaction will be spontaneous at high temperatures if the enthalpy change is large enough. Explanation. The Gibbs free energy equation or reaction to be spontaneous, dG must be negative. If dH0 and ds0, the reaction will be spontaneous at high temperatures because the term EDS will become large enough to make dG negative. Correct option is A. Key concept. Reaction is spontaneous when dG is negative, and it can be spontaneous at high temperatures if the entropy increase is sufficient. Question 27. Chemical equilibrium. Le Chatelier's principle. A solution is at equilibrium. 2 cert G plus O equals 2 cert G if the concentration of O is increased according to Le Chatelier's principle. Which of the following will happen? A. The equilibrium will shift towards the left, increasing the concentration of SO and O. B. The equilibrium will shift towards the right, increasing the concentration of SO. C. The concentration of O will decrease and SO will increase, but SO will remain unchanged. D. The concentration of SO will decrease, but the concentration of O and SO will not be affected. Answer B. The equilibrium will shift towards the right, increasing the concentration of SO. Explanation. According to Le Chatelier's principle, when the concentration of reactant is increased, the equilibrium will shift towards the product to consume the excess reactant. Increasing the concentration of O will shift the equilibrium towards the right, forming more SO. Correct option is B. Key concept. Le Chatelier's principle helps predict how equilibrium shifts when conditions such as concentration, temperature, or pressure are changed. Question 28. Ionic equilibrium. Buffer solutions. A buffer solution is made by mixing equal volumes of acetic acid CH and its conjugate base acetate in CH. If the concentration of acetic acid is doubled, what will be the effect on the pH of the buffer solution? A. The pH will increase because the acid concentration will cause more dissociation of the conjugate base. B. The pH will remain unchanged as the buffer system resists changes in pH. C. The pH will decrease as the increased acid concentration will shift the equilibrium towards more acid dissociation. D. The pH will decrease because the concentration of acetate ion will increase. Answer: B. The pH will remain unchanged as the buffer system resists changes in pH. Explanation: a buffer solution resists changes in pH when small amounts of acid or base are added. Doubling the concentration of acetic acid will increase the concentration of the conjugate acid, but the buffer will still maintain the pH by adjusting the concentrations of the acid and conjugate base according to the Henderson-Hasselbalch equation. Correct option is B. Key concept: buffer solutions can maintain a stale pH by neutralizing added acids or bases. Question 29. Atomic structure, quantum numbers and orbitals. Which of the following set of quantum numbers corresponds to an electron in a 3d orbital A equals 3 equals equals 1 equals 1 wo E equals 3 equals 1 equals negative 1 equals negative 1 wo E equals or equals 3 equals equals 1 wo E equals we equals 0 equals negative 1 wo. Answer: equals 3 equals 1 equals 1 wo. Explanation: for an electron in a 3d orbital, the principal quantum number n is 3 because the electron is in the third energy level. The azimuthal quantum number L for a d orbital is 2, and the magnetic quantum number m can take values from -2 to 2, corresponding to the 5 d orbitals. The spin quantum number s can be either 1 wo or -1 wo. The correct set of quantum numbers for an electron in a 3d orbital is equals 3 equals 1 equals 1 wo. Correct option is A. Key concept: quantum numbers define the energy, shape, orientation, and spin of an electron in an atom. Question 30. Periodicity. Trends in the periodic table. Which of the following trends is correctly described for elements across a period in the periodic table? A. Atomic radius increases across a period as additional electrons are added to the same energy level. B. Ionization energy generally decreases across a period as electrons are added and become easier to remove. C. Electronegativity increases across a period because the nuclear charge increases, attracting electrons more strongly. D. The number of valence electrons decreases across a period, leading to a greater ability to form bonds. Answer: C. Electronegativity increases across a period because the nuclear charge increases, attracting electrons more strongly. Explanation: as you move across a period in the periodic table, the nuclear charge increases, pulling electrons closer to the nucleus, which results in an increase in electronegativity. Electronegativity is the ability of an atom to attract electrons in a chemical bond, and it increases across a period due to the effective nuclear charge. Correct option is C. Key concept: periodic trends such as atomic radius, ionization energy, and electronegativity are influenced by changes in nuclear charge and electron configuration.